So our video for project number 3, the optical tachometer from Evan Walls and Jennifer Sparrow. So here's our board setup. We have a couple of IR LEDs, emitter and receiver set up here that are connected to an Arduino Uno R3. The receiver is hooked up to pin 2, which will be interrupt 0, and is also connected with a pull-up resistor of 10K. So when the beam between these two are broken, either by a finger running through it or through some kind of propeller spinning, that'll be displayed on our serial output here. You can see where my finger broke it. It went from 0 to 10 and then 19 for my finger being a supposed 10 rotations per minute through there. So here is the bag from the receiver and emitter that we used. We also tried to use this VS1838B IR receiver, which is this 3-pin guy right here, which turned out to be a pretty terrible idea. We couldn't get any consistent results from it. No idea why. We spent a lot of time trying to work on that, longer than I care to talk about, but that one didn't work out. So we just went with the single LED IR receiver and emitters. So our information is put out on the serial port, as you can see there. If I run my finger through it again, it'll generate another number, so finger's going 60 RPMs. We created the code in such a way that it accounts for the 3 splines of this fidget spinner, so when it spins through there, it does the calculations based on three sides of this running through. So if I go ahead and spin this cool pin one, if I can do it with one hand. So we'll put that in the middle there, and it's spinning, and up on the RPM counters we can see that it starts at 680 RPMs and is slowly working its way down as the fidget spinner slows down. There's a little bit ups and downs as it goes and reads some values that it thinks are faster than the previous ones, but eventually it will work its way down to 0. And it's stopped spinning now. So we should see 0 rotations per minute, and when I remove it, sometimes it hits the beam and knocks it up for a second. So me removing it knocks it up to 5. So last look at the board, the IR receivers and transmitters, and that's project number 3.